Hello, Charger folks. This is Mrs. Boyd. Today we're going to talk about areas of composite figures. What that means is there's not going to be a standard formula for finding the areas of these figures. We're going to have to be creative and use what we know to find what we need. So in this arrow that is here on your paper, I've given you all sorts of lengths and dimensions. And now we're going to calculate the area. I'm going to sneeze. So sorry. Area of this, I'm going to call it an arrow because let's be honest, that's what it is. But we're going to think of it as a triangle plus a rectangle. You know what? Let's do it like this. So we'll do the triangle calculations in red, the rectangle in orange. So this triangle, the base, let's first remember the equation for the area of a triangle is 1/2 the base times the height. So the base of this triangle is 2 plus 4, which is 6, plus 2, which is 8. So this base is 8. I'm not going to put it there. I'm so sorry. I've totally lost it. We're going to put something else there. So we're not going to write base is 8 there. We'll just jot it over here. Now, the other thing we need to find the area of our triangle is the height. And that's going to be from the highest point to the base. So let's use what else we know. We know that this length of this rectangle that we're going to find the area of is 5. And we know that from the very bottom to the very top, our area is 7. So that means if this is 5, this area is 7 minus 5, or 2. So our height is 2. It means the area of the triangle is, I'm going to call it area of the triangle, 1/2 the base of 8 times the height of 2. Half of 8 is 4, and 4 times 2 is 8. So 8 units squared for that triangle. Now let's do the rectangle. We know the area of a rectangle is the width times the height, or the length times the height, I guess is what we say. So our length is this side that is 5 units long, so 5. And then I guess that's the height, but then this end that's 4 will be our length. So we have 5 times 4, and that's 20 units squared. If we want the total area of the whole thing, we add the areas of the two composite parts. So we do 8 plus 20, and we get 28 units squared for the area of our total figure. So we're just going to use some creativity to find these. You can totally do it. So here, let's see. We can split up this guy in half like this, and we've got a parallelogram plus a parallelogram. So one parallelogram, the area, don't forget, is the length times the height, or the base times the height. So our base will be 6. So the base is 6. Let's look at this triangle here. This is an isosceles triangle that's made up right here. That means this line splits this side right down the center. So each of these lengths is 3. So the height of our parallelogram is 3. So that area is 18 units squared. Other parallelogram, base is 6, height is 3 again. So we have 18 more units squared. So that means our total area is going to be 18 plus 18. That's 36 units squared. All right, let's split up the next guy. We've got 2 rectangles here, it looks like. We have a rectangle plus a rectangle. I'm just going to call it rect. So the red will be the top rectangle. Let's see, it makes it important that these 2 sides are the same. So if the full side is 10, that means half of that side is 5. So the area of that top rectangle is 5 times 2, which is 10. Bottom rectangle, this length, like we said, is 5 as well. The bottom length is 10. So that area is 5 times 10, or 50. And these are both units squared. We want the sum, the total area. We'll do 10 units squared plus 50 units squared, and we get 60 units squared for our total area. One more on this side. We've got a circle-ish with a little bit of a square. So we're going to find a square, area of a square, plus 3/4 of a circle. Because this is 90 degrees, and 360 minus 90 is 270. If we want to find what percent, we do 270 over 360. And like I said, that'll be 3/4. So area of this square, that's the length of each side is 5. So our area is 5 times 5. That is 25 units squared. 3/4 of our circle, or the area of a circle, is pi r squared. But if we want 3/4 of a circle, we'll do the area of the circle is 3/4 times pi r squared. Well, it just so happens that this 5, that's the side of our square, is also the radius of our circle. So 3/4 times pi times 5 squared. So that area gives us 25 times 3 is 75. So 75 over 4 pi units squared. We make that a decimal. That'll be 18.75 times 3.14 is 58.875 units squared. Now we want the total area, and we do our square, which is 25 units squared, plus the circle, 58.875, and we get 83.875. Let me scoot it over, I'm out of space. Units, woo, that wasn't it. Units squared. All right, that's all on the front for our composites. Let's flip it over and look at shaded regions. It's going to be a whole lot similar, except for instead of adding things together, we're going to be subtracting this time. So this top diagram, we've got a rectangle with a circle inside, and we want to calculate the shaded area. So to do that, we're going to find the area of our rectangle, and we're going to subtract from that the area of the circle. So let's first find the area of the rectangle. If the side here is a length of 9, that means our area is length times width, so 9 times. Now we're going to have to be a little creative. This radius is 3, and it goes from the center of the circle to the outside of the circle, which is also the outside of the rectangle. We can assume that it's 3 in the other direction as well. The radius is 3, so that means the diameter will be twice that, or 6. So this length, which is also the diameter, is also equal to 6. So our area of our rectangle is 9 times 6. That's 54 units squared. Now, the area of the circle is pi r squared. So that's pi times 3 squared. We're going to use 3.14 and find a decimal for that. We get 9 times 3.14 is 28.26 units squared. So to find its shaded area, we'll do the area of the rectangle, 54 units squared, minus the area of the circle, 28.26 units squared. And we get 25.74 units squared. That's just the shaded region. So let's practice these a few times more. We want to know the area of all of these shaded regions. So we start out with this circle that is also shaded with a rectangle. So the circle's not shaded, but the rectangle is. So we'll have to do the rectangle, which really we can assume is this whole thing. So all that we'll have to subtract from it is a semicircle, or half of a circle. So the area of the rectangle is 4 times 8, or 32 units squared. The area of the semicircle is just going to be the area of a circle, 1/2 pi r squared, or pi r squared, and then we'll just divide it by 2. So 1/2 pi. We see 4 is the length of the diameter, so that means our radius is 2 squared. So that's going to equal, if we're going to give it a decimal value, 6.3 units squared. So our total area will be the rectangle, 32, minus the semicircle, 6.3, and that gives us 25.7 units squared. All right, now we're going to do the shaded region of the circle with the triangle inside. So we'll do circle minus triangle. Well, the area of a circle is pi r squared. We can see here that the radius is 4. So our circle area is pi times 4 squared, or 16 pi, or 50.3. The area of the triangle is 1/2 the base times the height, right? So we'll need to do a little magic here to figure out what these values are. We know that this value is 4 because it's the radius of the circle, and that's just also another radius. But what we need to know that we are not given is this length here. So I know that this length of the triangle is the hypotenuse here, what I'm going to call the hypotenuse. This length is 4. I've made a right angle by bringing this length down. So that's now a right angle. Can use what we did previously with the apothem ideal and find that this central angle is 360 over 3, which is 120. I divide that by 2 and get 60. So I know that this angle is 60. That means this guy is 30. And my hypotenuse is 4. So I can use a little trigonometry to find the length of this line. So if 60 is my reference angle and this is the adjacent line, I can do adjacent over hypotenuse is cosine. So the cosine of 60 is A over 4, adjacent over hypotenuse. I multiply the cosine of 60 by 4 to get A alone. Let me get out my calculator. And 4 times the cosine of 60, that means A is 0.5. Oh, just kidding, it's 2. Lord helps if you hit equals, right? Oh, goodness. So this value, A, is 2. That means our height is 6. I'm going to write it up here. Height of that triangle is 6. Now I need to know the base. So I'm going to use the sine. The sine of 60 is, we're going to call this length x. X over 4. So 4 times the sine of 60 is x. That means x is 3.46. That length is 3.46. That means our total base, we multiply that number times 2. So our base is 6.928. So area of our triangle is going to be 1/2 times 6 times 6.928. So, and that will give us 20.8. So total area or shaded region area, that is the area of the circle, 50.3, minus the area of the triangle, 20.8. And that total is 29.5 units squared. Whew. We're not going to worry with the last problem, so you can just mark that guy off and leave it for another day. I hope this makes some sense. I know it's kind of long and drawn out, but I think you can totally do it. Use some creativity on these. Let me know if you have any trouble, and I'll talk to you soon.